All right, thanks Glenn. Presentations looking at comparing the utilization of manure tankers, taking manure down the road, comparing those manure tankers in our corn side dress trials to dragline systems, looking at compaction in fields, and looking also at damage to roads from running all that manure down the road in the tanker system. So things we're going to talk about is, do manure tankers cause compaction? Do we need to be concerned about the tankers, their effects on their roads and their effects on local traffic? What have OSU studies told us about the possible compaction that these manure tankers might be causing? And then we're also going to kind of look at the cost of starting a dragline system. One of the things Glenn has a lot of hopes for, I guess, is he's done this corn side dress work. He talks about hoping producers will purchase and buy toolbars, go together, multiple producers in an area, get started in that dragline system, do their own barns, because there is a limited window, but it works really well. So you might have to have a few more toolbars, more hose in the area. So some different studies to look at to start with. A study out of Canada found that 43% of farmers won't even take free manure, those cash grain farmers that we're talking about, if it was given to them. Not because they don't think there's any value to the nutrients, they're concerned about the compaction that those spreaders are going to cause going across the field. And looking at that same study, when they looked at the damage spreaders caused, the average livestock farmer in the study was losing about $3,000 in grain value caused by compaction to their fields. There's a lot of ways we can reduce some of that compaction. Larger tires, of course, are going to decrease compaction depth, but the problem is, as we go with a wider tire, while we're not compacting as many inches deep, we can maybe get it back out with tillage. If we don't want to use those tillage tools, we just create a wire compaction swath, which actually can create more damage in the long run to those crop yields. Yields in compacted soybean fields without any manure application. So it's an interesting study. They used manure application, and they also didn't do any manure application because there's a benefit to that application. So if they just did a study where they applied manure to a strip and used that as their compaction compared to a no compaction strip that didn't have any manure, they weren't comparing apples to apples because of that manure application. But where they just ran the tanker over and, say, spread water on, the first year they saw a 4 bushel decrease in soybean yields, and the second year that carried through and still saw a 2 bushel decrease, just caused by tanker compaction from that spring application. Some things you can do on that manure tanker to help yourself out. Max axle loads on some manure tankers is up to 10 tons. In reality, you need to keep those axle loads down under 6 tons if you want to limit that soil compaction. And ground pressure is going to run about 1 to 2 psi's higher than what your tires are. In those tires, if you're having to run 30 psi, in order to maintain that tire quality with that heavy manure load in the tanker, you're actually putting probably 32, 33 psi's of ground pressure on those first few inches of ground. That's quite a bit of compaction if you think it through. So the ideal field tire pressure is going to be about 15 psi's. You can get those tires down to 15 as long as you keep them off the road. So the real danger in most of these tires is when you take off and go down the road, even if you only have a 20 mile an hour tractor, that 20 mile an hour going down the road on a 15 psi tire, it's flexing a lot, it's hard on rims. If you got your tractor tires down that low, I've seen guys that try to take tractor duals down to 15 psi and put a loaded manure tanker behind them, go around the corner and roll the tire off. So they're looking more at a 20 psi tire. That's more soil compaction. The ideal road pressure for most of these tires is to run about 35 psi's. So what can you do when you get to the field? Most ideally would be to use those manure tankers they talked about in the last presentation. Use that tanker, it hauls to the field for you, and then you're offloading into a tractor manure tanker that has those low psi tires on there to limit your compaction. Or some other examples, they actually make systems today that can auto-inflate. Within a minute of pulling into the field, it can inflate your tires down to 15, blow them back up to 35 to go down the road, help protect your tires and protect the soil. When you look across, looking at different axle loads, the heavier your axle gets, even if we run the same PSI in that tire, we keep going down deeper. 15 PSI tire pressure, we can see compaction all the way down to 2-foot depths. It might only be a 3 PSI compaction, but any compaction is going to be affecting that water movement, drainage, roots' ability to move through the soil. And of course, the wetter the soil is, if we're out there when we shouldn't be, we're going to have much deeper compaction, ideally. We're out there when it's dry. That's the great part about wheat. If you take the tankers out after a wheat crop, it's nice and dry in August. We don't see the same type of compaction as we do with spring, and we have some time for that soil to break up with a summer application versus spring application. But spring's when we're actually going to get the most benefit from those nutrients. At least last presenter showed about $40 benefit to the nitrogen. If you put it on in August, that nitrogen's not going to be there. You can't afford to truck it as far when you're losing all that nitrogen. So manure does have a lot of benefits. When we go back to that compaction study, once the manure was applied, yields are actually better than where they didn't see any compaction. So those benefits of the manure application outweighed the compaction cost. But if we could get rid of that compaction and get the manure out there, we're going to see an even bigger benefit. On headlands where manure tankers were ran, they saw 25 bushel less in the tire tracks, so right where that tire ran and turned across the headland. And if you went 30 inches away, they actually saw, I guess the 25 bushels was 30 inches away, and going 60 inches away, they still saw yield losses caused from that compaction as it spread out. So one way to get away from that, if we can use the frac tanks, if we're going long distances, bury underground piping, have more hose, we can get there with the dragline system, we're going to see a lot less compaction. We can keep those tractor tire pressures down, 12 psi's, maybe get them all the way down to 8, depending what type of system you're using. Go with a track tractor, get your eliminate tire pressure, lower ground pressure on the tracks. You're also not going to have that road damage if we're not using the tankers. Manure tankers are a lot worse than semi-tankers for the amount of road damage they're going to cause. It's typically much faster for at least a one-person job. Really, it's probably going to take you 2 for dragline. So we'll say a 2-person job, you can get a lot more gallons out through the dragline with 2 people than in 2 manure tankers. Typically 900 to 3,000 gallons per minute on PTO pumps. A lot of the PTOs are probably more like 1,000. Depends how large a tractor you put in front of it. There are quite a few hazards with the dragline system. Ruptured lines lead to spills in a hurry. You're not sitting right there at the line. Easy to shut off as much as a manure tanker is. Make a pretty big spill in a hurry, especially when we start going under roads. That's a road culvert, directly probably typical water flow. If we rupture a line going under the road, it's going to easily find its way to waters of the state. Another system is to pipe it up over the road. That works really well as long as a wide load doesn't come through and take out your pipe, or somebody that can't read comes through. There's a town just north of me that it seems like at least once a month the semi hits the railroad bridge going through town because he can't follow the truck route to go around the low-hanging bridge. Some other things to think about on that dragline system: you either need a continuous land base or you need neighbors that play nice. If you don't have that continuous land base and you're going to bury pipe, you need to be able to talk to them about burying that pipe. Or if you're going to run hose across the fields every year, you need them to be able to let you run across their fields with your hose, aluminum pipe, whatever you're using. Another challenge you can kind of run into with the dragline system is the drier manures don't flow as well. Anything over about 10% dry matter takes a lot of pressure and a lot more pump force to keep that moving and not have solids settling out causing problems. A lot easier to pump that drier manure into a tank versus running it across the dragline. Some other things to think about when you get into the too dry manure: you can use those boost pumps to help get it up out of the pit and then push it to your field pump that's going out to the field. And also another challenge is we like to run fields on an angle with that dragline system. You want your longest run to be your first pull, then continue getting shorter from there. You can run them, you can use hose movers and things, which is this middle tractor, to help with those longer fields or to help with odd-shaped fields. But if you get a really odd, unsquare field, dragline can be a lot more challenging than what a manure tanker is. There are some other options. Earlier today, Glenn mentioned running straight. You can run straight back and forth, either using a pull coupler or some sort of hose mover. Here, usually about a quarter-mile field is going to work a lot better than those half-mile fields. And when you're doing half-mile dragline pulls, that's putting a lot more stress on your hose, which can cause premature hose failures and causes those major ruptures that are a disaster. So really, ideal set size would only be about 40 acres, which could slow you down a little bit. Lengths can vary. Ideally, you're going to have a hose mover in there. If you have any sort of oddly shaped fields, which about 50% or better, your fields aren't going to be square. Pumps have to match hose size, depending how many gallons we're going to push a minute, and we don't want to have those solids settling out, especially when you're working with dairy manures. You're needing to move 1-2 feet per second of that manure speed velocity, so we're not having any solids settle out. At about 6 feet per second, we're actually pushing too much pressure through that hose, and we could actually burst a hose. To go further, if we want to go 20 miles away, probably every 2 miles we're going to have a pumping station that boosts that pressure back up and keeps it moving through the line. And some other things to think about if you're running the tractor: if you turn around too short and pinch that line off, it can create back pressure that will cause those lines to rupture. Some things to think about: community hazards. Some townships require written permission to be able to lay in right-of-ways. It's really nice if you can lay right down. If you have a large road right-of-way, run those hoses down the right-of-way. But some townships in different states, I don't know of any in Ohio, but require written permission and proof of liability insurance if you're going to lay those hoses through their right-of-ways. Fields are definitely covered much faster, which can also lead to some manure leaching issues. You definitely have to be more cognate, do a better job of watching those tile. If you're used to applying with a manure tanker and only getting 10 to 15 loads out a day, and you go to cover a whole 40-acre field in one day instead of just 10 acres of it, and then it rained, there's a lot more potential for nutrients to move off of that field because we put them on a lot quicker. There's also this major problem if we would use the tanker trucks of roadway damage. So an 80,000-pound semi, which is legal, your 6,500-gallon tankers full of manure is probably more than 80,000 pounds and not legal. It takes about 12,000 passes to cause roadway damage on your typical state route. If we take an average manure tanker that's only weighing in at about 71,000 pounds, 10 passes of that, because it's wider, running closer to the berm of the road, can cause that same damage of 12,000 passes with a legal manure tanker, or legal semi-tanker. Those semi-tankers are a little bit narrower. Typically you're going to keep them a little further away from the berm of the road. And the other thing on a semi-tanker is bridge laws. We get that long tanker, we got a longer bridge, more distance between axles, the road has more time to come and go and respond. It doesn't just get crushed under that load weight. 20%, anytime you have a 20% overload, you're going to increase road damage. Move loads over at least 16 inches from the edge of the road can decrease that damage by 75%. So if we run those manure tankers more towards the center line, or if it's an open road, if we start straddling the center line, keeping away from the berm of the road by about 16 inches, we decrease that roadway damage and can make more passes, keeping the state and township happy. Axle number was also more important than tire size. So the more axles we had underneath that load should do a better job of spreading the load out across more surface area, not just going wider on tires. We decrease the amount of road damage we're going to see. Some of these slides are actually borrowed from Fred Whitford from Purdue, looking at some road hazards to pay attention to that we're going to find on these rural roads. Don't be the guy that sees the 5-ton bridge and says, I've gone over it twice before, I can just keep going over it all day. That 5-ton bridge, there's a reason it has that sign. And if you decide not to follow it, if you make it across, the bridge will fall in the water. I took out the other fun picture. If you only make it halfway across, the tanker's stuck hanging there with the rear axles in the river and the truck up on dry ground. Some other things to watch out for if you're running a whole fleet of tankers. Put some space between them. Don't be the truckers that don't let the grass grow between the two trucks, because you're going to be moving a little bit slower than traffic, and it's much easier for the car that's in a hurry to zip around you once, get in between the two of you, and then be able to pass again instead of having to pass a double train or a triple train of manure tankers going down the road. Left turns, of course, are the most risky factor going on when we're traveling down the road, whether in semis or in tractor tankers. Even if we use our turn signals, people are on this little device in their hand, probably the most dangerous thing ever invented, and they're watching it, not what's going on in front of them, and you start to turn left while they're trying to pass, and you end up with a crunch situation. Like this guy, sprayer was trying to turn left, the truck decided to go around him and got squeezed off the road. Here you have the concrete truck, there's a car between it and the sprayer. What if you're the guy right back here behind the concrete truck and you're in a hurry, you're only going 25 mile an hour, 35 behind that piece of ag equipment, you don't even know it's up there. You just think there's a concrete truck, so you decide to zip around and the sprayer decides to turn left. One way to remedy that is, before you start to go, slide over so they can see you more around when they just start to pop their nose out. As long as the road's clear in front of you, you can slide over to start to make your left turn and make yourself seen. Of course, make sure your lights are working. There's some different theories on lights. Running the hazard lights, some people say, becomes monotonous and people just see the blinking lights in front of them and don't pay any attention to when the turn signal comes on. If that's the case, run the hazard lights, but put another system on for turn signals that basically lights you up like a Christmas tree when you're turning. Get their attention, whether it's multiple strobes that kick on, whatever you need so people can see you. So we can stay safe on the roads, and then we want to use this manure when it's most needed. So if we can use that in the drag line, what kind of compaction are we causing? What did the OSU research tell us? Well, we have 54 studies looking at in-growing corn side dress manure applications. 42 of those studies were with field tankers. Of those, 21 of them had positive yield results that averaged 4 bushel better than manure when the manure was applied versus the commercial fertilizer. And then we had 10 non-compaction trials. Those non-compaction trials are either dragline trials or small plot trials. The reason why we can call small plot trials non-compaction trials, our tanker actually straddled 4 rows and we only harvested the center 2, so those rows didn't have any compaction damage to them. Of those 10, 7 of them had positive results. Averaging all 10 trials, we saw a 16 bushel advantage in the non-compaction trials to manure over commercial fertilizer. One of the non-positive trials there that wasn't a compaction trial was using beef manure, and in that case we didn't do a very good job of getting that manure covered, so we think a lot of the nitrogen was lost. So that leaves 2 trials we can't explain of why they were non-positive, but they also weren't ever statistically different when the manure was used and it was less than the commercial fertilizer. So with that in mind, we definitely see about a 12 bushel advantage to eliminating that compaction from the manure tanker out of the equation when we're going to side dress this corn. And really we go from a 50% chance of having better yields to 70% chance of using manure and getting a better yield than with the commercial fertilizer. So if we wanted to do this, we need to set up our own dragline system. What's the cost going to be for this system? So if you're going to go with a tractor-operated pump, it's going to move about 1,000 gallons a minute. You're going to be somewhere between $7,000 and $13,000 before that pump is usable. You might be able to tell me you can go out and buy one of these pumps for $4,000 or $5,000. By the time you get it home, open it up, the impeller is going to be shot and the pump housing will be shot. Nobody sells anything that's actually ready to go when it leaves their farm. They wore it out. Then you're going to need a hose cart. You don't want to be out rolling up a couple thousand feet of hose by hand, so you're going to need some sort of hose cart. Most hose carts are going to run somewhere between $7,500 for a used hose cart to $22,000 for that newer hose cart. Hose anywhere from $7 to $18 a foot, depending what size of hose you choose, anywhere from about a 5-inch hose up to a 10-inch hose. I'm going to say you need a minimum of about 1,980 feet to go from a hog barn that's really close to your field and go across that field. Ideally, you're probably going to have more like at least a half mile, 2,640 feet to cover that. That hose is going to run you somewhere between about $13,000 and $36,000, depending what size hose you go with and how many feet you get. Some other things you're going to need, if you can borrow the county applicator while we're still doing research trials. For side dress, you wouldn't have an applicator on there. If you want an applicator that's set up for that side dress, you're probably looking at somewhere between $30,000 and $70,000. You can get some used applicators, more down around $15,000 to $20,000. It just depends how worn out you're willing to purchase. If you're going to be in that standing corn or you want to do those odd-shaped fields, hose movers, a new hose mover runs about $8,500. You also need a good old air compressor. So after you've applied to that field, you have to have a way to blow that hose out, get the manure out of it, especially if you're running under any road culverts. So you put a pig in, which is a foam ball or a foam bullet, and then you push it with air and that'll clean that entire hose out, and you can keep applying to the field so that you can clean up a clean hose and get it out of the road ditches or wherever you ran it through. So you're probably looking at $70,000 to $150,000 to get a dragline system set up. So it is a little bit more probably than just going out and purchasing a manure tanker and a pump tractor to fill it. Some other things you need that aren't even in there you're going to need that tractor to go on the pump, 200 plus horse, if you're going to keep your gallons up. Dragline tractor, 250 is probably the minimum. Most guys are looking more like a 400 horse tractor on that applicator. And they're also trying to find row crop tractors with a 3-point hitch. That's the big problem, is if you have a 4-wheel drive, it doesn't have that 3-point hitch to pick up the toolbar to be able to side dress corn. Some other things you're going to need, be easy to find, be the hose cart tractor. Hose menders can add up, along with hose pinchers, things to shut that hose off. The average custom applicator surveyed in Illinois had about $500,000 invested. Now that commercial applicator, he's making his living. That machine runs all year long whenever he can get across the field and there isn't a crop there. So you are going to be a lot less than that, but it does add up. So how much does application cost? This study comes out of Idaho. When we look at average cost of application, with a manure tanker with knife injection, we're looking at about an $80 application cost. If we would do broadcast, we're looking at about $65 using those manure tankers. Drag hose injection, we're down around $70 to $75 for application costs. That's applying about 7,500 gallons. If we add in a manure tanker so where it says no tanker versus with tanker, the no tanker is just having that tractor and tanker run back and forth from barn to field. With tanker has a semi nursing it. We save about $10 by having that nurse semi, speeding us up, saving time. Application cost is fairly linear, coming out of an Iowa study. If you're going about 5 miles, in Iowa it's going to cost you about 2.7 cents a gallon to move that manure 5 miles. And when you get up to 25 miles, typical cost out of Iowa would be about 9.7 that a custom applicator would get for moving and applying that manure to your farm. If you take this equation, it's about 35 millionths of a cent for every mile you add on, with about 1 cent per gallon initial cost. Some other studies that look at application, that Iowa study per 1,000 gallons, about $14.75 with injection using a manure tanker. If you use dragline, it was about $13.30 per 1,000 gallons. New York custom applicator study looked at 27 farms using tractors and tankers, was about 1.13 cents a gallon. And using a haul, transfer, and spread, so using that semi to haul to the manure tanker out in the field, they were about 1.3 cents a gallon for application. The last time we had enough people respond to the Ohio custom rates survey on 1,000 gallons for pump and spread, not split out by drag lines or tankers, for 1,000 gallons in Ohio, we're running about $8.50 per 1,000 gallons. And since 2001, I can guarantee that's trended up. Hopefully, in the next custom rates survey, we get some more people to respond so we have better Ohio data. But manure is not cheap to move. Does anybody have any questions?
Some of the applicators on the back of the tanks, how does that help with the compaction issue?
It's kind of going to depend, I guess, what type of applicator you have. So when you go back to some of those compaction studies, they're showing manure tankers compacting down to a 2-foot depth. So if you're running a Dietrich shank at 4 or 5 inches, you're really not going to alleviate that deep compaction. And if you're going to run a VIT coulter, you're probably only going to alleviate top compaction, the top 3 or 4 inches, and about 6 inches of that field where that tire ran, where your tire's probably going to leave a 1.5 to 2 foot footprint per tire. So it's really not going to alleviate that deep compaction. It might help a little bit with surface sealing, but it won't get rid of deep compaction.
If you go ahead and rip it deeper with the tool, won't the manure reach down a little faster?
Yeah, the deeper you go, the lower that manure is going to get into your soil. So then it's just going to depend what type of soil structure you have. The deeper you go, it changes the risk of getting it into your tile system, depending on what type of soils you have, how much macro flow and everything else you have.
Thank you, Jason.
Yep, you're welcome, Glenn.